Okay, here we go. I wanted to show you guys what progress I've made so far with the Arduino and Qt library making a GUI application. So what I did first to monitor this data for the RFV device was I took the data set that Ken had given me some time ago. It's basically that 5 minutes of data, and I just put it into a CSV file. This is just a little comment I have at the top here. But basically I just wrote all this data to a file on the Arduino micro SD card and put it in to the Arduino, uploaded some code that I wrote, and here's the code basically, and let me plug in the Arduino device. And the Arduino has a serial port, and so you see the data coming. I'm sampling basically at 50 Hertz, so there's 1,000 lines per second or 1 kilohertz sample rate, and I'm sampling every 20th line. And you can just kind of see here if I turn off auto scroll for like these are the seconds, and since the Arduino is based on an AVR and it doesn't have a floating point library, I multiplied everything by 1,000 just to get a whole number or an integer here, and we'll end up using a timestamp from the desktop or laptop and not from the Arduino. But for right now, this is what I did, and you can see here that I've actually grabbed every 20th line. Since there were 1,000 of the since there are 1,000 of these in the file, 1,000 lines, you can see here, if you imagine a decimal point there, this would be at 351.226 seconds, 0.227, so on and so forth. So all I did was I went through and I grabbed the 20th one in code. I read each line, but I actually sampled the 20th one in this code, and now when you run it with the Arduino, you can see that it's actually streaming. So the Arduino is basically just simulating the RFV device sending data to a laptop. We're using the serial port, and we'll use that protocol with wireless, but for right now I needed a way to simulate the device. So once I got that working, then let me close that, and then what I did was I made an application in C++ and Qt, and this is just the interface that I made at first, basically just so we have something to work with. Ken might recognize this, or Robert, you might as well, or may as well rather. This is a work in progress, but for right now it's good enough. And just here's some of my code that I have, a couple of different classes, so on and so forth. So if I just run this data, or run this program rather, the program will start, and once it starts, I can just find the serial port here. I capture the port, it reads the port, it's ready. Now I don't have a graph implemented yet, but you can see here that the data is actually updating here. Let me move this out of the way. The other thing to notice is that here it's moving. You can kind of see it. It's going kind of fast, but you can see that these are individual lines being read. They're being read in as a byte array, and basically the records are 22, 23, or 24 bytes in size, and the Arduino is spitting them out over the serial port, one byte after the next, with a new line character at the end, and my Qt code is reading that and reading in up to the new line, and once it does that, I have a whole record, and then I actually parse through that record and get time, EKG, I wave, Q wave, and mean blood pressure. Just again as a way to simulate some data coming to us, whether or not we use all those parameters, fewer parameters, more parameters. Right now it's irrelevant. This is just a test to do it, like, you know, to just get some data flowing. So the next step here, I mean, you can just watch this go. The next step here would be to make this form larger and implement a real-time chart so it will display the data that we want. And I'm kind of thinking now that we probably the time frame will actually go on the x-axis, so that there won't be a time here, but the EKG, I wave, Q wave probably would be probably would be displayed together. Certainly the I wave and the Q wave would be. So I got to play around with that a little bit, learn the real-time chart that I have a demo for. This has taken me about a week and a half to get this going. I'm still learning the Qt library, so it takes a little bit of time to hunt things down, but for the most part, that's it. This will read the entire file, and just the data will stop, and of course the chart will stop as well. So the nice thing about this is that we can get the raw values printed out here, but we can also, if we make the form bigger, I mean, you can make, there's a lot of real estate left here. You can make the form bigger, and you can actually have the raw data showing up in smaller fields if we want, and then perhaps we'd have another group box over here with, depending upon what algorithm we were testing, if we were checking area under the curve, if we were integrating, if we were, slope of the curve, the instantaneous slope is the derivative. If we were going to do that math, we would do that in another thread, and we could display the results. Note here, by the way, that this is still running, and this is very responsive. I can do whatever I want, where if this had been, well, that indicates that this is threaded, meaning that there's one thread that operates or controls, runs the code, if you will, that handles the GUI. But there's another thread that's actually reading the data from the serial port, and then it's giving that data to the GUI to update the numbers. So all the GUI thread has to do really is just sit there and update these numbers, and the processor is actually doing a pretty good job, because we're taking advantage of the fact that I have a multi-core processor. Let me just show you here how this works. If you just watch, you'll see I have a quad-core processor, and all four cores, all four cores of the processor have 2 threads, so it's a hyper-threaded processor. So that's why I do the operating system. It actually looks like there's 8 cores, and you'll see here the activity. I don't really have much else running other than the video recorder app, but you see here that there's high levels of activity on a couple of those cores. And let me just make this a little smaller so we can see all this. So something like that, you can kind of see that we have a fair amount of activity on more than one core here, but not a ton. I mean, all 8 cores, there's 2 cores that are busy most of the time. And again, we're running the screen recorder and in HD, and I'm running the operating system and so on and so forth. So most laptops should be plenty able to handle this. I guess that's the point I'm making. When we're actually reading data from a subject, most laptops should easily be able to handle this, even if they're a dual-core laptop that's hyper-threaded, so you've got really 4 cores being used. If you're threading this application, when it runs, this is one process, and within the process there are 2 cores, one to do the main GUI and one to do the worker GUI or worker thread for the read and queuing up the data, as it were. We'll have another thread that does calculations, obviously, and that will also queue up information for more of these. So we don't want the GUI to ever be non-responsive. So, but anyway, that's basically what's going on, and it's a work in progress, but hopefully another week or 2 and I'll be displaying data on a chart, and then we can start to talk about what sort of information we want to process, or what algorithms we want to try, or what, so on and so forth. But that's it.